This is your review of Unit 2, which covers the atom. First thing you should be able to do is to classify matter. Now, an element is going to be something that has only one kind of atom. If you look up on the table of elements, all of those elements up there are made of only one specific type of atom. Next are compounds, and those are made of two or more kinds of atoms, which are chemically bound. You can only break those apart by performing a chemical reaction or through it going some chemical change. Last, we have mixtures. A mixture is going to be something that's physically mixed together. So it could be two or more kinds of atoms, but they're only physically mixed together. And you can separate these based on properties, physical properties, like boiling point or melting point. So here's a couple for you to look at. Classify the following as an element, a compound, or mixture. So the first one there is gold. That's obviously going to be an element. If you look up on the table of elements, that's symbol AU. Next one is sterling silver. Now this one's sort of a trick because you see silver there and you think, oh, well, that's an element, but there's that sterling in front of it. This is actually an alloy, which is a mixture of silver and copper. Again, remember that alloys are mixtures of metals, which improve the properties of the individual metals. So pure silver is way too soft to be made into jewelry. So we mix it with copper to make it a little bit harder so that way it can withstand daily wear and tear. Next one is methane. A good hint that this is a compound is you see how it's written. It's written as a chemical compound, CH4. That's methane. Same deal with potassium permanganate. The K is the potassium. The permanganate is the MnO4 polyatomic ion there. That's also a compound. Last one that we have is brass. And again, that is an alloy. That is a mixture of copper and zinc. We actually made brass whenever we made our gold pennies about halfway through the semester. Okay, so this table is very important because it summarizes all of the facts about the subatomic particles. There are three subatomic particles that we learned about: the proton, neutron, and electron. So the proton starts with a P. That's going to have a positive charge, also starts with a P. The neutron is neutral, and the electron is negative. The proton and neutrons together, those make up the nucleus. Each of them has one atomic mass unit. Now, the electrons orbit around the nucleus. And whenever you think about it, the mass of the electron is nothing compared to the mass of a proton or neutron. It's sort of like a proton or neutron would be an elephant and an electron would be like a feather. Yes, the feather does have mass, but whenever you compare that to the mass of an elephant, it's nearly nothing. So that's where the mass number comes from. Most of the mass of an atom comes from protons and neutrons. So if you add those together, you get the mass number. To figure out the atomic number, you're going to look at the number of protons. This is printed right there on the periodic table of elements. It's the big number that's in bold. A clever way to help you remember this is AP, because we're all going to take AP Chem. At least we hope so. So A stands for atomic number. That's the A in AP. And P stands for number of protons. That's where the P comes from. So that's just a way to help you remember that the atomic number is the number of protons. To figure out the number of neutrons, you're going to have to take the mass number and subtract the atomic number. So again, the mass number is the sum of protons and neutrons because that's where most of the mass of the atom comes from. The atomic number again is on the periodic table of elements. You just subtract these two and what you're left with is the number of neutrons. So mass number is protons and neutrons. If we subtract the atomic number, which is just protons, what we're left with is neutrons. Lastly, for electrons, to figure out how many of them we have, you're going to have to look at the charge. If there is no charge, aka a neutral charge, that means there's just as many electrons as there are protons. So remember, a proton is +1 and an electron is -1. Those two cancel each other out. In the event that there is a positive charge, that just means that you have more protons than electrons. So you can take protons and you can subtract the charge. Lastly, if the charge is negative, that means that there's more electrons than protons. All you have to do is take the protons and add the charge. Last thing that you should know, this layout here that we have the mass number over the atomic number, then the element symbol and the charge, you'll need to know that layout and you need to understand how to take the information that we have up here and how to convert that into the mass number, atomic number, and to write it out in this format. So here's a table, and you can see there's a lot of holes in the table. You should be able to fill this out using nothing more than a table of elements. And again, I put down here this format to remind you. Here we have the mass number. Okay, so that corresponds to this number up here. Then we have the atomic number, which corresponds to this number down here. We also have the charge. Okay, so here you can see the charge is written as superscript. And then in the middle there, you've got the element symbol. In this case, it's sodium. So just to remind you again about how to fill this in. First, the atomic number. You get that by looking at the table of elements. Next up is protons, which is going to be equal to the atomic number. Then we have neutrons. You do mass number minus atomic number to figure that out. Then for electrons, that's where you got to look at the charge. If there is no charge, that means there's just as many electrons as there are protons. If there is a positive charge, you're going to take protons minus the charge. And if there is a negative charge, you do protons plus the charge. And lastly, that leaves the mass number, which is just going to be the sum of protons and neutrons. So to go out and fill out this table, for A, we got the symbol here, and this has got all of the information that we need to fill the rest of this in. So you need to know what these numbers mean and where they come from. So first, the atomic number, again, that's the one down here on the bottom, is 11, which means that we have 11 protons as well. Next up is the number of neutrons. So that's going to be mass number minus atomic number. The mass number in this case is 23. The atomic number is 11. So 23 minus 11 gives you 12. Next up we have electrons. So we see that we have a positive charge here. So that means we need to take the protons, 11, and subtract 1. So that gives us 10. Another way to do this is just to look at the charge. Since this is +1, and I know that for it to be positive, I need more protons than electrons. I know I have one more proton than electrons. So if I have 11 protons, I must have 10 electrons. Lastly is mass number. We're just going to add protons and neutrons there. So 11 and 12 make 23. So that was a good example of going from the symbol to figure out all of these different columns here. In the next one, we don't have the symbol. So what we're going to need to do is figure out what goes in all of these other blanks before we write our symbol. So first blank is given to us, the atomic number, which means that we're also given the number of protons because that's equal to atomic number. We're given neutrons and electrons, but we don't have the mass number. So we got to figure out what the mass number is, and that's just the sum of protons and neutrons. So 20 plus 21 is going to make 41. So now that we have all this information, we're ready to write our symbol. So the mass number, that's the first thing we need to know. That's 41. check, that's done. Next one, atomic number, that's 20, check, that's done. Then we come to the element symbol. So the element symbol in this case, if you look at your table of elements, look for atomic number 20. That corresponds to calcium. So I know the element we're talking about here is calcium. That leaves the last thing for me to figure out, which is going to be the charge. Again, we're looking at the number of protons and electrons, seeing how those balance out. So we see that we've got 20 protons and 20 electrons. So that balances out to a neutral charge of 0. So there it is. Now I do want to draw your attention here to the 0. The 0 here. A lot of times that won't be written in if it's neutral. If you see it, you should know that that means neutral, but it may not necessarily be written in there. So, next one, letter C. Again, missing a lot of blanks, but we're going to be able to fill them in. So we fill in these guys first, then we can do the symbol. So, first blank that we come across here besides the symbol blank, we need to do that at the end, is atomic number. Now, atomic number is equal to the number of protons. So we got 20 protons here, so we know the atomic number must also be 20. Next blank to fill in is the number of neutrons. So let's look at what we have so far. We know the mass number, which is the sum of protons and neutrons. That's 40. And we know the number of protons. That's 20. So if we take the mass number and we subtract the atomic number, the difference is going to be the number of neutrons. So we're going to do 40 minus 20 to get 20. Last thing we have to do now is to fill in the symbol. So what goes on top is the mass number. We have that right there in our table. That's 40. Then the atomic number, again, 20. Then we have to figure out the element symbol. Again, the atomic number is 20. So we look on our table of elements. We see that atomic number 20 corresponds to calcium. What do you know? Just like in B. Then we come to the charge. So again, we want to see how protons, which are positive, balance out with electrons, which are negative. We got 20 protons and 20 electrons, so again, the charge is 0. Alright, last one to fill in, that's D. We're given protons, neutrons, and electrons, so the rest is easy. 11 protons, that's equal to my atomic number, 11. I just got to figure out the mass number, and that's just the sum of protons and neutrons, so that's easy also because it's 11 and 12. So those add up to make 23. Last thing we need to do is our symbol. So the mass number, 23, that's what's going to go on top. The atomic number, 11, that's what goes on bottom. And then we have the element symbol. If you look on the table of elements, atomic number 11 is sodium. So the last thing that we need to do is figure out the charge, and we're just going to figure out how positive protons balance out with negative electrons. There's 11 of each, so there's no charge. It's charge 0. Now, at first glance, it looks like I've just given you 2 atoms of sodium and 2 atoms of calcium, which is accurate. But the difference here is in these mass numbers and in the charges. So if you look at B and C, they're both calcium atoms, but the difference between them is the mass number. So what this means is that they have the same number of protons, but they have a different number of neutrons. So B has had one more neutron than C. Same deal with D. They have the same mass number, they have the same atomic number, same symbol, but what's different there is the charge. A has a positive charge and D has a neutral charge. So the next couple of questions asks you which 2 are isotopes. So you need to know the definition of an isotope. Isotope is going to be 2 atoms that have the same atomic number, so that bottom number is the same, and they have different mass numbers, so the top number is different. Another way of stating this is saying that they have the same number of protons. Remember, atomic number is the number of protons, but a different number of neutrons. That's where the variation comes in the mass number. So the two that fit this description are going to be B and C. Next up, which has more electrons, A or D? That's going to be D. It's got a neutral charge, so that means that it's got the same number of protons and electrons. And in this case, that's going to be 11. Whereas A has a positive charge. That means that it's got one less electron than protons. So the answer there is going to be D. Next up is Rutherford's gold foil experiment. You should be very familiar with this by now. In class, I set up a bunch of styrofoam balls hanging from the ceiling. Those represented the electrons. And then I hung up a textbook in the middle of the ceiling, and that represented the nucleus. So what happened was Rutherford shot alpha particles at a thin layer of gold atoms, and this was gold foil, a very super thin layer of gold foil. We simulated this in class by throwing a lacrosse ball, which represented our alpha particles, through our atom that we had set up hanging from the ceiling. So what he saw was that the particles would bounce back only whenever they hit the dense, heavy, positively charged nucleus. Whereas 95% of the time, the alpha particles would just fly straight through the gold foil. And that's because the atom is mostly empty space. We have the dense, heavy nucleus made of protons and neutrons, and then orbiting around that is our electron cloud. Of course, Rutherford didn't know all of this, but based on the results of his experiment, he was able to figure out that there must be something dense and heavy in the middle of the atoms, and the rest must be empty space. Few words about electrons. So here in this figure, I've got the atomic nucleus right there in the middle, and then each of these different layers here represent the different energy levels. Now, remember, the energy levels are quantized, so that means that I'm either in the first energy level or I'm in the second energy level. There's no 1.5 energy level. I'm on one or I'm on the other. There's no in between. So whenever electrons gain energy, they bump up in energy level. If they're given just the right amount of energy to only jump up one level, that's all they're going to jump up. If they're given enough energy to jump up 1.5 energy levels, they're still only going to go up one energy level because the energy is quantized. Whenever they relax and they fall back down in energy level, the energy is going to be released as visible light, and the color depends on how much energy was released. So in class, we did a flame test. And in the flame test, we took little sticks that had been soaked in solutions of various metal ions. And depending on the identity of the metal ion, it was a different color. So what was happening there was whenever we passed the stick that was soaked in the metal ions through the flame, we excited all of the electrons all the way up to their highest available energy level, and then they simultaneously fell back down. So that's why we only saw one color of light. It would be possible if we could feed the atom these discrete levels of energy, it would be possible then to see many different colors from one atom. So next question asks you about how to do the Lewis dot structures. So basically what we're doing is we're indicating the number of electrons in the outermost energy level, that's the valence shell, using dots. So for BE, if you look on the table of elements, you see that that's in the second column. If you look up at the top, there's Roman numeral 2. That tells you that it's got 2 valence electrons in its outermost shell. Next up is carbon. And carbon has got 4 valence electrons. So I indicate that with my 4 dots. Now there's a pattern to these 4 dots. The pattern is just going to be top, that's 1, right, that's 2, bottom, that's 3, and left is 4. So you go around in that pattern until you've counted out the correct number of electrons. Next example is chlorine. Chlorine's got 7 valence electrons. If you find chlorine on the table of elements, you'll see that above it, it's got a Roman numeral 7, and that's just letting you know how many valence electrons are there. So again, the pattern that we used here was top, right, bottom, left, then top, right, and bottom. So that took care of our 7 electrons. All right, so that covers Unit 2. Here are some key ideas that you should remember while studying. First, it's very important that you are able to find out the number of protons, neutrons, and electrons when given the atomic number and mass number. You should also know where to find these numbers given the symbol. If you're not sure what I'm talking about, go ahead and review that subatomic particles table that we filled in together. Next, you need to understand the basic properties of subatomic particles, so charge, location, weight. Make sure you know those.